morning, my YouTube viewers. It is Crystal here. Anyway, I want to make another video because I took a course with Alison, and the course that I've taken is called Probability and Chance in Mathematics. I thought it was a good course until I got to the assessment, and then when I got to the assessment, I realized that a lot of the questions that they asked on the assessment either were not covered in the course or were not covered enough in the course. But fortunately, I was able to complete the assessment, and I was just using the assessment kind of like as practice questions because I had to go onto the internet to find the answers to the questions. Now, I've been studying statistics for quite a while now, so I recognize the questions, but because I don't really do statistics in my day-to-day job, I have to keep doing it over and over again. So this course with Alison is Probability and Chance in Mathematics, and I'm going to do it in 3 videos. So I'm going to do Module 1, Module 2, and then the assessment. And then I'm going to go back and do 3 more videos, and I'm going to do it in Excel and show you how to perform all these computations in Excel. And the reason for that is because I use Excel in my day-to-day job, and I pay for Excel. And I figure, well, if I'm paying for Excel, I may as well use it and make videos on it. So that's what you're going to get. You're going to get 3 videos on Python, and you're going to get 3 videos on Excel, so you can check the videos that you want. So the first video is we're going to be covering Module 1. So we've got a question of how many different combinations can you arrange 8 books. So we're doing this in Python, and we're using Google Colab to write these programs. So we're going to import math, which is an inbuilt library in Python. So arrange books equals math.factorial 8. A factorial is when you multiply like 8 times 7 times 6 times 5 times 4 times 3 times 1. But instead of doing all that by hand, we're just going to use the factorial function, and the factorial function will do that. So you have 40,320 different ways that you can arrange 8 books. And so now we have a question of how many different combinations can you arrange 8 books in a bookcase of 5 books. So arrange books equals 8 times 7 times 6 times 5 times 4, because you only have 5 slots. And since you only have 5 slots, you can't do the factorial. I wish you could. I wish that you could do the factorial, but you can't because there's only 5 slots in there. So we have the next question. They said, what is the mean of a fair 6-sided die? So a fair die is like a die that hasn't been weighted in any way. So the num sides is 6. The total equals 0. For I in range 1, num sides plus 1. Total equals total plus I. Mean equals total divided by num sides. And then so you're going to print the total, and you're going to print the mean of the die. And so your total is 21, and 21 divided by 6 is 3.5. The next question is, what is the probability of finding an ace or a spade in a deck of cards? So the probability of finding an ace in a deck of cards is 4 divided by 52. The probability of finding a spade in a deck of cards is 13 divided by 52. An ace or a spade equals ace plus spade minus 1 divided by 52. Because you have to remember that one of the aces is a spade. So you have to subtract 1 from that. And then so you print that out, and the probability is 0.30769. So we have the next question. What is the probability of finding a tail and a 2 and a coin and die? So the probability of tail is 1 divided by 2. A probability of 2 and a die is 1 divided by 6. Probability of tail and 2 equals prob tail times prob 2, and that's going to be 0.08333333. So that's how you do that. And then you can say, got another question. There is a class of 30 students. 20 students study chemistry. 6 students study biology. 4 students study both chemistry and biology. Show that the events of chemistry and biology are independent. So probability of chemistry is 20 divided by 30. Probability of biology is 6 divided by 30. Probability of chemistry and biology is 4 divided by 30, and probability of chem and bio equals probability of chem times probability of bio, and that's true. So it means that probability of chem and bio equals probability of chem times probability of bio, and that's true. The next problem we have is probability of rolling 2 6s in 2 rolls of dice. So probability of 6 is 1 divided by 6. Probability of not 6 is 5 divided by 6. Probability of 2 6s is probability of 6 times probability of 6, and that's 0.277777. Okay. Next question we have is, what's the probability of 1 6 in 2 rolls of dice? So probability of 6 is 1 divided by 6. Probability of not 6 is 5 divided by 6. Probability of 1 6 equals probability of 6 times probability of not 6 plus probability of 6 times probability of not 6, and that's 0.277777. Next question we have is, choose 1 man from 3 men and 7 women. So 1 man is 3 divided by 10. 1 woman is 7 divided by 10. Probability of one man is 1 man times 1 woman, and it's 0.21. Next question we have is, we have a bag of balls, 4 blue, 3 yellow, 2 pink. 4 blue equals 4 divided by 9. Yellow equals 3 divided by 9. And pink equals 2 divided by 9. And probability of selecting the same color twice is 2 blue equals blue times blue. 2 yellow equals yellow times yellow. 2 pink equals pink times pink. And then you have the probability of selecting the same color. So probability of same color equals 2 blue plus 2 yellow plus 2 pink. And then we print off 2 blues, 2 yellows, and 2 pinks as 0.1975. Yellow is 0.1111, and pink is 0.049. And then probability of selecting the same color twice is 0.3580. Now the probability of selecting different colors equals the probability of the same color. It's 0.64. So now what we're going to do is we're going to talk about the Bayes theorem. And Bayes theorem is something that I'm really interested in and I would like to learn more of. So we're going to talk about reverse probability using the Bayes theorem. Probability of machine 1 is 0.6. Probability of machine 2 is 0.4. A machine 1 with no defect is 0.95. A machine 1 with a defect is 0.5. Machine 2 with no defect is 0.92. Machine 2 with a defect is 0.8. So we find the probability of the defect. So probability of machine 1 defect equals machine 1 times machine 1 defect. Probability of machine 2 defect equals machine 2 times machine 2 defect. Probability of machine 1 no defect equals machine 1 times machine 1 no defect. Probability of machine 2 no defect equals machine 2 times machine 2 no defect. And then so we print all that out so you can see the probability of no defect on machine 1 is 0.57. The probability of defect on machine 1 is 0.3. Probability of no defect on machine 2 is 0.36. A probability of a defect on machine 2 is 0.032. And then what we're going to do is we're going to, from 1,000 items, calculate the total number of defective items. Num items equals 1,000. Num defective equals num items times probability machine 1 defect plus probability machine 2 defect. And so we print off the number of defective items, and that's going to be 62. Then we check the probability of defective items from machine A, or that's machine 1. Probability defect A equals probability machine 1 defect divided by probability machine 1 defect plus probability machine 2 defect. And we print that out, and it's 0.48. So that's your probability, and that's how you do Bayes' theorem. So now we have another question. We're going to have, this is a question about disease, which I find to be quite interesting. And so that's something that people in the medical field are going to need to know about. So a true positive is individuals are correctly identified as having disease. A true negative as individuals correctly identified as not having a disease. False positive is individuals incorrectly identified as having a disease, and false negative is individuals incorrectly identified as not having disease. So probability of disease is 0.02, probability of not disease is 0.98, sensitivity is 0.95, and specificity is 0.96. So now what we do is we calculate the true positive, the false negative, the true negative, and the false positive. So true positive equals sensitivity times P disease. False negative equals 1 minus sensitivity times P disease. True negative equals specificity times P not disease, and false positive equals 1 minus specificity times P over not disease. And then so we display our results. So true positive is 0.190, false negative is 0.001, true negative is 0.9408, false positive is 0.0392. And now we say out of 10,000 people, the number of positive test results is, so you have num people is 10,000, total positive equals num people times TP plus FP. And then so we print total positive, and so that's going to be 582. And they say, what is the percentage of people who have disease? So people disease equals true positive divided by total disease plus num people. And so that's going to be 0.3264. So we're going to do this question again. We're just going to do it again in a different way. So P disease equals 0.02. P not disease is 0.98. Sensitivity is 0.95. Specificity is 0.96. And total people equals 10,000. So we calculate TP, FN, TN, FP. TP equals sensitivity times P disease plus total people. FN equals 1 minus sensitivity times P disease times total people. TN equals specificity equal times P not disease times total people. And FP equals 1 minus specificity times P not disease times total people. And then so now we calculate the positive test results. Positive results equals TP plus FP. Calculate percentages. Percentage positive results equals positive results divided by total people times 100. Calculate percentage with disease equals TP divided by total people times 100. So we print the results. The percentage of people with positive test results is 5.82, and the percentage of people who have the disease is 1.90. So now we're going to look at probability patterns of discrete variables. So we're going to look at dice. So each number on a 6-sided die is going to have a probability of 1 divided by 6. So total die equals 1 divided by 6 times 6. And so it should be 1. And then we're going to check the weight of a coin. So you've got a coin, and this is a weighted coin. So 0 is 1 divided by 4, 1 is 1 divided by 2, and 2 is 1 divided by 4. And so the total coin equals 0 plus 1 plus 2, and that's going to give you 1 as well. So that's it for this particular video, because we have completed Module 1. And the next module is going to be Module 2, because I don't want to make the videos too long. I mean, I could sit here and go through everything, but the video might be an hour long, and you might get tired of watching the video. So that's why I want to make the video short. So this concludes Module 1 of the course, Probability and Chance in Mathematics. In the next video, we're going to be talking about Module 2. Thank you very much for watching my video. If you like my video, please like and subscribe. And I look forward to making a new video for you soon.